3.3, the unit circle and circular functions. So circular function, a unit circle has its center at the origin and a radius of 1 unit. The trigonometric functions of angle theta in radians found by choosing x and y on the unit circle can be written as functions of the arc length, a real number. When interpreted this way, they are called circular functions. So for any real number, s represented by a directional arc of the unit circle, so sine s equals y, cosine s equals x, tan s equals y over x, cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. So meaning the negative one, so here the negative 1/2 square root of 3 over 2, so this would be x, y, and then we also know now that x represents, well, we've kind of known this, x represents cosine, and y represents sine. So if we wanted to find tangent, it's sine over cosine, which we now know is y over x. And that's why it would be 1 over y, 1 over x, x over y for cosecant, secant, cotangent. The unit circle is symmetric with respect to the x-axis, the y-axis, and the origin. So no matter how you fold it over, it's symmetrical. That's why all of these points match, because it's symmetrical. Symmetrical means the same. For a point on the unit circle, its reference arc is the shortest arc from the point itself to the nearest point on the x-axis. For example, the quadrant 1 real number pi over 3 is associated with a point 1/2 square root of 3 over 2 on the unit circle. So let's find that. If we went to pi over 3, that's right here. So you see how it's associated with 1/2 and square root of 3 over 2. And it's also 60 degrees. Because cosine s equals x and sine s equals y, we can replace x and y in the equation of the unit circle, x squared plus y squared equals 1. Alright, so this is the unit circle. I've kind of already talked about how you need to memorize this. You have to memorize it all. There are videos out there. You can watch my video, that's how I remember how to do it, or you could just Google or go to YouTube and put unit circle. There's so many tricks and tips on how to memorize this, and honestly, I know it looks really, really difficult, but it's super simple to memorize this. I am horrible at memorizing things. Like, I'm a flashcard person. I really have to regurgitate it so many times. But this unit circle, super duper simple to memorize. Don't be scared of it. Just watch the videos, really get to it. Okay, so some extra information that doesn't really pay off right now, but it's going to come up very, very soon. Domains of certain things. So remember, domain is what x or s in this case can and cannot be. So for sine and cosine, your domain is all real numbers. Tangent and secant, your s such that s cannot equal 2n plus 1 times pi over 2, where n is any integer. And for cotangent and cosecant functions, we have s such that s cannot equal n times pi, where n is any integer. That does come back, I promise. Alright, evaluating a circular function. Circular function values of real numbers are obtained in the same manner as trigonometric function values of angle measured in radians. This applies both to the methods of finding exact values, such as reference angles analysis, and to calculate approximations. Calculators must be in radian mode when finding circular function values. So meaning, if you're working with radians, it should be in radians. If you're working with degrees, you should work with degrees. Alright, finding exact circular function values. Use the unit circle to find the exact values of cosine 7 pi over 4 and sine 7 pi over 4. So let's first remember cosine represents x. So what we're saying is we want to go to 7 pi over 4 and look at the x for 7 pi over 4. So let's go to 7 pi over 4 on the unit circle. 7 pi over 4 is right here. So the x, which is cosine, that is associated with it, is square root of 2 over 2, and the sine, or the y value, is negative square root of 2 over 2. So cosine s, which represents x, so cosine 7 pi over 4 equals square root of 2 over 2. And then our sine function, which represents y, it was, so sine 7 pi over 4, it was negative square root of 2 over 2. And we just look at the unit circle. We look at a pretty picture, and that's it. Alright, example 2. Find the exact value of tangent negative 5 pi over 3. So tangent is not on the unit circle. The only thing on the unit circle is sine and cosine, but we know how to find tangent. So the first thing we're going to do is just go to negative 5 pi over 3. Okay, so we have tangent, I'm going to put it up here so we can reference it. We have tangent negative 5 pi over 3. Now, this radian is negative. There are no negative radians on here. So 5 pi over 3 in the negative direction is 1, 2, 3 little dots in the negative direction. So what we need to do is in the positive direction go 3 dots. So in the positive direction we're going to go 3 dots. So we start off at 0, we go 1, 2, 3. Those are the values we're going to use. So we're going to use 1/2 and square root of 3 over 2. So I'm going to do that one more time with you guys. So we have a negative radian measure. Because we have a negative radian measure, we need to be careful. So let's go. So we're starting at 0. Negative means down. So how many points, how many dots to get to 5 pi over 3? 1, 2, 3. It's 3 dots to get to 5 pi over 3. So then I need to go 3 dots in the opposite direction to get the actual value. So I'm at 0, 1, 2, 3 dots. We're going to be using 1/2 and square root of 3 over 2. So we know that tangent is the same thing as sine over cosine. So we can plug it in. So sine over cosine, that's y over x. So sine, we have square root of 3 over 2. Cosine, we have 1 over 2, which leaves us with just square root of 3. So tangent negative 5 pi over 3 is square root of 3. Okay, so I'm going to add an extra example here just to kind of help us with that negative portion. So let's go ahead and find cosine negative 4 pi over 3. Okay, so we're talking about the x value here. So starting at 0 and it's negative, so let's figure out how many dots does it take us to get to 4 pi over 3 in the negative direction. So 1, 2, 3, 4, 5 dots. So it takes us 5 dots in the negative direction to get to where we need to go. So now at the positive direction, I'm going to go 5 dots. So starting at 0, 1, 2, 3, 4, 5. So this is the point we're going to use. So the cosine of that point is negative 1/2. Alright, example 3. Use reference angles and radian to degree conversion to find the exact value of cosine 2 pi over 3. So 2 pi over 3, is that on the unit circle? Yes, it is. You could find cosine 2 pi over 3, which is negative 1/2. You could. Yes, but I'm not trying to teach you that. I'm trying to teach you a concept, an idea that you are going to use later on. So let's convert this to degree because it's telling us to use reference angles and radian to degree conversion to find the exact value. So let's convert that to degree. So 2 pi over 3 into degree mode. So we would have to multiply. So 2 pi over 3 times 180 over pi. And we get our degree mode of 120 degrees. So 120 degrees, that lies in quadrant 2. That's in quadrant 2. So cosine in quadrant 2 is negative. So cosine in quadrant 2 is negative. And remember, I'm using cast, C-A-S-T. So quadrant 2, cosine is going to be negative. Alright, so now we know we're working in quadrant 2. So we're in quadrant 2, and we have this angle of 120 degrees. So now we need to find our reference angle. So to find our reference angle, we do 180 minus 120, and we get 60 degrees. So this right here is 60 degrees. So now we know we have a 30, 60, 90. So if that's 60, this is 30 degrees, and this is 90 degrees. So we know something about 30, 60, 90 triangles. So we have cosine 2 pi over 3, which we turned into cosine 120, which we know as the reference angle. The reference angle of that is 60. And we know that cosine 60 is negative 1/2. So yes, that was the long way around it, but it's just the idea that I want you to get, that if we can't find a value, switch it to degrees and see if we can figure out if it's a 30, 60, 90 or a 45, 45, 90 triangle, or if we can figure out other things about it. All right, example 4. Find an approximation for each circular function value. So we have cosine 1.85. You see how there's no degree symbol there? That means your calculator must be it must be in radian mode. So make sure your calculator is in radian mode, and we just need to find cosine 1.85, cosine 0.15149, cotangent, and secant. So the first two I'm not going to do with you because it's just pressing the button. It's literally pressing cosine 1.85. But C and D I'm going to do with you and kind of explain a little more about those. Alright, so we want to make sure we're in radian mode. Okay, we're in radian mode, so we're good there. So for the first two, you just literally press cosine or cosine again and type in the number, and that's it. Hit enter. But for cotangent, remember, cotangent is not on the calculator. So since it's not on the calculator, we need to do the reciprocal, which is 1 over tangent our value. So we plug it into our calculator, and then we get our value. So again, secant is not on the calculator. It's not, but we know the reciprocal is secant. That's why we do 1 over cosine, the value they give us. Alpha y equals enter, 1 over cosine negative 2.9234, and we get our value. A common error is using a calculator in degree mode when radian mode should be used. Remember, if you are finding circular function values of a real number, the calculator must be in radian mode. Also, if you're not working with degrees, then you're working with radians, keep it in radians. Example 5. Finding a number given its circular function value, approximate the value of s in the interval 0 to pi over 2 if cosine s equals 0.9685. So what we're doing is we're trying to find theta. We're trying to find the sector length. Remember, sector length is just theta. This is radian, this is degree. So they're meaning the same thing. So if I said we have cosine theta equals 0.9685, wouldn't you do the whole little inverse thing? We would do theta equals cosine negative 1, and then we would put our 0.9685. So that's what we're going to do with our calculator. We do inverse of cosine, radian mode. Why radian mode? Because this doesn't say degree, so we're working in radian mode. Now, what does it mean for 0 to pi over 2? We want to make sure that it's in that quadrant. So this is quadrant 1. So quadrant 1. We're working in quadrant 1 here. So when we plug it into our calculator, we want to make sure that that value, 0.2517, actually is in quadrant 1. How do we figure that out? How do we know if it lies between quadrant 1? I'll show you. Then you'll always just remember this. So quadrant 1 is between 0 and pi over 2. So we know 0 is just 0. So let's figure out what is pi over 2. Pi over 2 is 1.57. This number is in between 0 and pi over 2. Our domain is 0 to pi over 2. So this does fall between 0 and pi over 2 because pi over 2 is 1.57. Which 0.25 is less than 1.57 but greater than 0. So it does work out. Alright, so next we're going to find the exact value of s in the interval pi to 3 pi over 2 if tan s equals 1. Alright, so now we're talking about tangent. Tangent is not on the unit circle explicitly. It is if we figure it out though, right? It's sine over cosine. So I'm going to explain how to do it with your calculator, and then I'm going to explain how to do it by hand, and you need to know both. first thing we do, right? We do, this is the same thing if we did the tangent theta equals 1. So if we have tangent s equals 1, right, we move it over. So we have s equals the inverse of tangent 1. So we plug that into our calculator. So inverse tangent 1, and we get our value. But we're in this quadrant. We're in this quadrant. Pi to 3 pi over 2. What quadrant is that again? It's quadrant 3. So we're working in quadrant 3. Let's figure out if this is in quadrant 3. You're probably telling yourself no. So quadrant 3 is pi. So quadrant 3 is 3.14. And then 3 pi over 2 is 4.71. So on. I'm not going to write them all. So this does not fall into that quadrant. So we need to get it into this quadrant. We need to get it between these two numbers. It's like coterminal angles. We need to get 0.78, that value, we need to get it in between 3.14 and 4.71. So how we're going to do that? Well, we're going to add by pi's until we get that value. Because right now we're in quadrant 7.78 is quadrant 1. So to get it into quadrant 3, so right now, this is where we're at. We need to get here. So to get there, past that point here is pi. So I need to get past pi. I'm going to add our value that we got to pi, because I need to get past pi to get into my quadrant. So I'm going to add it to pi, and I get 3.92. So we have our tangent, so we have our value of 3.926990817, and that is the value of s. Now we should check it. Why should we check it? Because we had to add something to get to the quadrant we needed. So let's check our answer. To check our answer, we're going to plug it back in. So we're going to do tangent s. So this is the value of s. It should equal 1 when we plug it in. So we do tangent, and then our value, so that's our value, highlight it, press enter, and it equals 1. So it checks out. That is the answer. So that's how we would use our calculator. This is approximate form. This is approximate form. So what this is saying is that tangent whatever equals 1. So we need to figure out, remember, tangent whatever is sine over cosine. If we need to get to 1, isn't 1 like 4 over 4, 100 over 100? Isn't 1 the same thing over the same thing? So we need to go to our unit circle to find same over same, and in what quadrant are we working in? So we need to look in quadrant 3 if there is a sine over cosine if two numbers are the same. So let's go to quadrant 3. So we're in quadrant 3 now. So we're in this quadrant right here. So we need to look for two numbers that we put on top of each other that equal 1. So they have to be identical numbers. We're going to use this one right here, 5 pi over 4. So in quadrant 3, we know 5 pi over 4 equals square root of 2 over 2. Sorry, negative square root of 2 over 2. And negative square root of 2 over 2. So if we plug that in, we have tangent 5 pi over 4 equals sine over cosine, so negative square root of 2 over 2, negative square root of 2 over 2, it equals 1. So our answer would be 5 pi over 4. This is our exact answer. What we did before is our approximate answer. And you could check, you could use your calculator to see if those numbers are actually the same, and they are. If I did 5 pi over 4, see how we get the same exact values? Example 7. Modeling the angle of elevation of the sun. The angle of elevation theta of the sun in the sky at a latitude L is calculated by the formula sine theta equals cosine D, cosine L, cosine, that's W, but it's actually omega, plus sine D sine L, where theta is 0, corresponds to the sunrise, and theta pi over 2 occurs if the sun is directly overhead. Omega, which we just say W, is the number of radians that the Earth has rotated through since noon, where W is 0. D is the declination of the sun, which varied because Earth is tilted on its axis. Sacramento, California has a latitude L of 38.5 degrees or 0.6720 radians. Find the angle of elevation theta of the sun at 3 p.m. on February 29, 2012, where at the time D is approximately negative 0.1425 and W is 0.7854. Okay, so we are going to find the elevation of the sun at this specific time of day, this specific day in Sacramento, California. 100% factual, by the way. This is what we're doing. All right, so we're going to use our formula. Why we're going to use our formula? Because it says to find the angle. Angle means theta. So we're going to be using our formula of sine theta equals cosine D, cosine L, cosine omega. We just do like a W with a loop through it, plus sine D sine L. So we need to figure out our variables for D, L, and W. So let's go ahead and find that. It tells us D is this. It tells us W is this. And then it tells us the latitude of Sacramento, L, 38.5 degrees. But we're not using degrees here. No, we're going to be using the radians. All right, let's plug it in. So we have sine theta equals cosine D, which is negative 0.1425, cosine L, which is 0.6720, and then we have cosine W, which is 0.7854, and then we're going to add that to sine D, which is negative 0.1425, and then sine L. So sine L, which was 0.6720. Alright, let's plug that all into our calculator. Literally, that whole right side we're going to plug into our calculator. Alright, so we have cosine negative 1.425, so negative 0.1425. Then we have cosine 0.6720. Then we have cosine 0.7854. Then we're going to add that to sine negative 0.1425, so negative 0.1425, and then sine 0.6720. Welcome to higher level math. Plugging in really long formulas into your calculator. And we hit enter. So we get sine theta is approximately 0.4593426188. And now we need to find theta, so we do the inverse. So we have theta equals inverse sine. And then we're putting this value in here that we just found. So we have second sine. I'm not going to type that all, so just highlight it and press enter. Hit enter one more time. Does that like match up anywhere? Is that the degree of the sun? Pay attention to what it's really asking. Find the angle of elevation. Find the angle of elevation, theta. Remember, theta means degrees. That's not degrees. What mode were we in? We weren't in degree mode. See how easy it is to make that mistake. right? Because this entire time, example 1 through 6, we're working in radian mode. But right now, just because we missed that little detail of find the angle theta, we forgot to put it in degree mode. So go back and put it in degree mode. So go to degrees, hit enter, press second mode. All we need to do is just do this again. So highlight it, hit enter, and there we go. That's a normal number. Most degrees are above 1 when we're talking about the elevation of the sun. So we should have known 0.47. That doesn't seem right. That doesn't seem like the right answer. So that kind of had us go back and say, I forgot to put it in degree mode. I purposely did that so we would kind of go through that thought process. So when you're doing your homework and your test, if this happens to you, hopefully it can spark up a memory. So we have our answer. We have theta is approximately 27.3 degrees. And we do it to 3 significant digits because it's 38.5 degrees. So the angle of elevation of the sun in Sacramento, California on February 29th, 2012 at 3 p.m., it was 27.3 degrees. Because when the sun sets, it goes like this. So this is 0 degrees, pi over 2. So this is noon. That's noon. So 27.3 degrees, that's about like right here, which is about 3 p.m. Because remember, the sun sets on the west coast in February much earlier than here. We have longer days because we're close to the equator, but up there in February, it probably sunset is about 4:30, 5 o'clock. That cool, right? So cool.